Hey Bio Team. So our first unit focuses on the stuff that living things are built out of. And when we say stuff, we mean the molecules that they're built out of and the different types of elements inside of those molecules. Living things are fundamentally different from non-living things. And part of that is due to the fact that they're made of a special type of molecule called organic molecules, which are molecules that contain carbon inside them, specifically carbon that's been bonded to hydrogen. So what's so special about carbon? If you can remember all the way back to chemistry class, you'll remember that carbon has 4 valence electrons out of a total of 8 that it would need to be stable. So it has 4 unpaired valence orbitals where it can form bonds, covalent bonds, with up to 4 different other atoms, which is the most out of any element on the periodic table. And so it can form bonds with terminal atoms like hydrogen here. And so we'll show carbon bonding to a couple of hydrogen atoms. But it can also form bonds with other central atoms like other carbons. And these central atoms are able to bond with other central atoms. And so it's possible for carbon to form gigantic molecules called macromolecules, and these molecules are complex enough to build living things. So there's 4 types of macromolecules. There are carbohydrates, which are types of sugars. There are lipids, which are fats. Proteins, which are the cell's tools and building blocks. And then there are nucleic acids, which provide the code for building certain types of proteins. And as mentioned on the previous slide, all of these elements are organic. That is, they all contain carbon bonded to hydrogen. But from there's different elements involved. For instance, carbohydrates have carbon, hydrogen, and oxygen. And they're always bonded in a 1 to 2 to 1 ratio. So an example of this would be something like glucose, which is C6H12O6. It has carbon, hydrogen, and oxygen in a 1 to 2 to 1 ratio if you were to reduce it. Lipids, meanwhile, or fats, also have carbon, hydrogen, and oxygen, but it has a much lower ratio of oxygen. So we'll show you a picture of a common type of lipid called a fatty acid. And you can see it has much less oxygen compared to carbon and hydrogen than the carbohydrate. And then also worth noting is that lipids can also have phosphorus in them. And this is particularly useful in the phospholipids that form the membranes around cells. Proteins, meanwhile, in addition to carbon and hydrogen, have oxygen, nitrogen, and sulfur in them. And this allows the proteins to fold into really complicated 3-dimensional shapes that can be used for all sorts of things inside of our cells. And then last but not least, the nucleic acids have carbon, hydrogen, oxygen, nitrogen, and phosphorus. And so the 2 main categories of nucleic acids are RNA and DNA. And it's the phosphorus inside of the backbones of these molecules that can help make them stable, which is good for long-term storage of genetic code. And when we say backbone, we're talking about the outside edge of this helix here. And that's it. At this point, you guys have some practice problems. Best of luck.